I am very proud of my new application, but it will only take 1 minute of my time to hack it. Watch me do that. I have logged in as user 1, and this is the page displaying companies I'm managing or working with. However, what I don't know is that I am under attack. The hacker is signing in as user 2, using their own credentials. There is nothing fishy yet. This is that user's data, but they only created those to collect information about the system. For example, here is the workflow to edit the company's details. Change a field, save it, see it modified. The hacker is ready. Let's edit the company one more time. What is the hacker doing? Well, this individual has a secret weapon. They can forge the HTTP request. I have found the HTML form that will post the data back to the server. I have located the field with the company's identity. You may think that you are safe if you use GUIDs, but you are not. GUIDs are not cryptographically secure. Hackers can use brute force attack combined with other techniques to target valid GUIDs. A malicious user may have guessed the GUID of my entity. The hacker posts the modified form. Their data look the same as before? That's because the hacker did not modify their data. Let's see what user 1 is seeing this time. I'm logging in as the first user, which is supposedly the real me. Going to that page with the company data, and there you see it. I've been hacked. A malicious user has been able to cross the user boundaries and write data into another user's object. That is one of the most dangerous vulnerabilities your application may experience, and I have seen all sorts of code that make these attacks possible. I will now demonstrate how this issue occurs in code. I will then show you a simple fix for it, and then I will teach you a general fix that will ensure that nobody can ever repeat this kind of attack on any page in your application. Stay with me, it's gonna be a wild ride. What you see here is the post-action handler when editing a company. That was the page the attacker used. Let's see what this handler does. It fetches the company entity by its ID. That was that GUID the hacker has overwritten. Then it modifies the fields, followed by an update to the repository and a commit on the unit of work. Can you spot the issue? I'll give you a moment to think. In the meantime, take a glance at the company model. Besides its own ID, it also carries the identity of its owner. That is the user who created the company in the database, and that is the only user who should be able to see or modify this company entity. The security issue is somehow connected to this owner property. Do you see the issue now? Here it is. My code does not verify the company ownership before changing it. That opens the door wide for anyone to attack the application. But that is only one half of the problem. The other half is the company's repository, which performs CRUD operations on the company entities. While that Razor page has manipulated the data to facilitate a successful attack, the repository did nothing to stop the impossible data. Read the query. It filters by the company's ID and the deleted flag, which implements the soft deletion. The query doesn't check the owner before returning the record. The security vulnerability is now complete. Neither the application layer nor the database layer has done its job to protect the logged-in user from inadvertent modification to their data. Now that we understand the problem, we can begin to address it. Look what the post-action handler does when it begins. It looks up the company by its identity. But what if the company does not exist? It redirects to the company's page. I could have returned a 404 not found response. It doesn't matter. Only a hacker can mistake an ID. Now, what response should be if somebody wanted to gain access to somebody else's entity? Well, the answer is obvious. 404 not found, or safely redirecting to the main page. As far as the current user is concerned, such an ID doesn't exist. Again, a regular user would never encounter this scenario. I will implement that solution now. You see, the entire edit company page is requesting authorization with the user role. I will read the identity of the currently logged in user. This identity will be the mandatory filter in all SQL statements. Let me use it to fix the post action that modifies the company entity in the database. This first operation will look up the company by the ID, just as it has always done. But then comes the check of the user ID. Only if both IDs match shall we retain this object. Otherwise, we shall pretend as if it didn't exist in the database. The security hole is now plugged. No hacker will ever fetch somebody else's company to edit it. Now repeat this for every post action on every page in the application and you will be safe. Unless you forgot a page or two. That's the issue with this approach. I should call this a poor man's security. I will now present a general solution which will be simpler yet more effective than the idea I have shown you here. If you have enjoyed the video so far, please consider joining the growing community of supporters on my Patreon page. This channel is free thanks to the patrons. If you choose to become a patron, you will get access to the source code for all the videos on my channel, as well as some additional materials not available on YouTube. You will find all relevant links in the description. I will now show you the most powerful solution to guarding users' data. The revelation will come if you look carefully into the domain model again, but this time with a changed perspective. Ask yourself, why does the company entity know about its owner? What will it ever do with this property? The answer is nothing, ever. Access validation belongs to the application layer. The first step to better security is to remove any knowledge of authorization from the domain model. The places where the code does not compile will tell where the fixes are due. Look at the company's repository again. It doesn't compile because it doesn't know the identity of the user who owns the company. Adding a new company to the database fails to compile because the repository doesn't know the user whose company that is. Who will tell the owner's identity now? The repository will. This is a change in mindset. The repository will now take part in securing operations. The logged-in user will own the repository the same way they own the database records. The user's identity will become a mandatory parameter when creating a repository. That is the prerequisite to augmenting the SQL code to filter the rows by the owning user. Now comes the SQL code. Finding the company will also include the owner's ID. The method would return null in case of a hacking attempt. The next operation to consider is adding a new entity. It is implicitly setting the owner ID. That is correct. Updating the entity would follow the same protocol. The repository will only update objects owned by the logged-in user. Authorization is becoming a part of every SQL statement. This operation looks up the database ID from the GUID. Not anymore. It is GUID plus the user's identity. That ultimately brings us to the place where repositories are instantiated. This occurs in the unit of work, which is responsible for tracking repositories and managing the transaction. The unit of work will now require the user for its repositories. In a way, the unit of work and the entire database transaction will also be owned by the currently logged-in user. This change was easy to implement, yet it will make a dramatic impact on the application. All repositories will share the same user identity with a transaction. The user's identity will be included in all transfers to and from the database. I must not forget to fix the composition root. The compiler is already warning me of a missing constructor parameter. Creating a unit of work is more engaged now because for every instance we must discover the current user. This completes the entire secure infrastructure for my application. Let me show you the Razor pages now. Editing a company will return to its original simple form. There is nothing to check anymore. Yet the operation will be secure because the repository would never fetch or modify somebody else's company. What about the page that creates a new company? It won't be dealing with company ownership anymore. That remains the business between the application layer and the database layer. My application is now safe from that particular attack vector. That attack falls under the name Insecure Direct Object Reference, which is one of the most prominent classes of security threats today. I would love to hear that your application is secure from issues of this kind. Go check your code and fix it today if you must.